All right, let's jump right into a pretty wild idea. We all know we need oxygen, right? It's the stuff of life. But what if I told you that the very molecule that powers everything we do is also, well, working against us? We're about to explore the absolutely incredible two-faced nature of oxygen. I mean, really let that sink in for a minute. The process that gives us life is at the same time chipping away at us, contributing to how we age. It sounds like something out of a sci-fi movie, but believe it or not, it's happening inside every single one of your cells right this second. So how on earth is that possible? Well, let's find out. You know, the story really starts with a simple, unavoidable fact about how our bodies work. When we use oxygen to make energy, it's not a perfectly clean burn. There are always byproducts, and some of them, well, they're more than a little unruly.
And this is where we meet our main character for today, reactive oxygen species, or ROS for short. These are basically the troublemakers. Think of them as unstable, supercharged forms of oxygen that get spit out as a side effect of just, living and breathing.
So where do most of these things even come from? What's so fascinating is that the scene of the crime is actually inside our own cellular power plants, the mitochondria. It's kind of like an assembly line for energy. As electrons get passed down the line, a few of them inevitably leak out. And when a stray electron zaps a nearby oxygen molecule, boom, a ROS is born. But here's the thing, not all ROSs are created equal. Some are just minor annoyances, but others are full-blown cellular villains. So, let's get to know the main suspects in this little origin story. Here's our lineup. Over on the left, you've got your regular, harmless molecular oxygen. But as it gets hit with those stray electrons, it starts to morph into these much more volatile characters, like superoxide. And eventually, the one we really have to worry about, the hydroxyl radical. And this is how the bad guy gets its upgrade. It all starts with superoxide. That's the first radical that's formed. Our bodies are pretty good at dealing with it, and they quickly turn it into hydrogen peroxide. Now, hydrogen peroxide is a bit more stable, but it's just one step away from becoming the real monster. See, when it bumps into metal ions, like iron, inside the cell, it gets this massive power-up and transforms into the hydroxyl radical. And this brings us to the absolute crucial point. Our cells have systems, enzymes, to clean up superoxide and hydrogen peroxide. But, as this quote points out, we have no built-in defense against the hydroxyl radical once it's made. It's like a ghost in the machine. It's unbelievably reactive, incredibly destructive, and there's just no off switch. So, what happens when this ultimate villain is let loose inside our cells? Well, it causes just widespread collateral damage. We call it oxidative stress, and it kicks off this destructive domino effect. The hydroxyl radical is not picky at all. It will attack literally anything in its path. It smashes into the lipids that make up our cell membranes, making them all weak and leaky. It crashes into proteins, bending them out of shape so they can't do their jobs anymore. And, maybe most critically, it strikes our DNA, causing tiny mutations that can build up over a lifetime. And this just brilliantly illustrates how it's not just a one-and-done kind of damage. When the lipids get hit, the whole cell membrane starts to fail. That messes with ion transport, which drains the cell's energy. At the same time, the damage to DNA and proteins also feeds into this energy drain. It's a cascade, a feedback loop where one problem just creates another and another, all spiraling down toward total cell failure. Okay, so that all sounds pretty grim, right? But hold on, because our bodies are not just sitting ducks here. We have this highly sophisticated, multi-layered army that's totally dedicated to fighting back. Let's meet the cellular cleanup crew. Our whole defense strategy is basically two-pronged. First up, you've got the heavy artillery, the enzymatic first responders. These are proteins designed to neutralize ROS with just incredible speed and efficiency. Then you've got the ground troops, the non-enzymatic scavengers. Think vitamins from your diet. They act like a mobile defense force. Check this out. This is our star enzymatic team in action. First, an enzyme called SOD, that's superoxide dismutase. It tackles that initial superoxide radical, turning it into the less scary hydrogen peroxide. Then, before that can get upgraded into the monster hydroxyl radical, another enzyme, catalase, swoops in and neutralizes it, turning it safely into just water and oxygen. It's an absolutely elegant 1-2 punch. And here's our scavenger squad. And notice how they all have their own specialties. Vitamin E, it's lipid-soluble, so it's the bodyguard for our cell membranes. Vitamin C is water-soluble, so it patrols the watery parts of the cell. And then you've got glutathione, which is often called the master antioxidant. It not only neutralizes ROS itself, but it also helps recharge other antioxidants like vitamin C. It's a real team effort.
Okay, so up until this point, it's been a pretty clear story, right? ROS are the bad guys, antioxidants are the good guys. But the real story? Well, it's a lot more complicated. And this is where things get really, really interesting. Prepare for a bit of a plot twist. So are Rs always the enemy? What if I told you that our bodies don't just put up with Rs, but sometimes they actually create them on purpose? What if these destructive little molecules actually have a vital, even heroic role to play in keeping us healthy? Yeah, you heard me. They're weapons. When your body gets invaded by bacteria, your immune cells intentionally unleash a massive flood of ROS, it's called a respiratory burst, to literally obliterate the intruders. They're turning the destructive power of these molecules into a precision-guided defense system. And that is not all. At low, controlled levels, ROSs are essential messengers inside our cells. They're part of this huge, complex communication network that tells a cell when it's time to grow or divide, or even when to, self-destruct for the greater good of the body. They are a fundamental part of how our cells talk to each other.
And this quote from the source material just sums it up perfectly. ROS are a true double-edged sword. If you have too many, you get damage, aging, disease. But if you have too few, you mess up essential things like your immune defense and cell communication. The key isn't to get rid of them. It's all about balance.
So, when you boil it all down, the big takeaway here is that life isn't about avoiding stress entirely. It's about managing it. This whole drama inside our cells shows us that a little bit of stress, a few of these ROS molecules, isn't just good, it's absolutely necessary for life. The real challenge is just maintaining that delicate equilibrium. And it really makes you wonder, doesn't it? What does that balance between beneficial stress and harmful damage look like in our own lives?